So today we will continue seeing how to simplify rational expressions, but today we will see how to simplify it when we have polynomial denominator. So remember, a polynomial is composed by at least two terms, two or more. In this case, it's going to be super important to remember the factoring cases. Why? Because in order to simplify our rational expression, we must factorize our polynomials. Why do we need to factorize our polynomials? Because remember, we cannot eliminate like this 5 with this 10 because we have an addition and subtraction on the bottom. So in order to eliminate terms, they must be factors, something between parentheses or something that multiplies and other stuff. So let's see how to do this kind of exercise. It's going to be we must factorize them and eliminate the factors we can or simplify the factors we can. Let's see the first example. On this one, on the bottom part, we have a binomial. Both terms have something in common, so we can take out a greatest common factor. The greatest common factor on the bottom is going to be 5a cubed b squared. So if I take out the 5a cubed b squared, it's going to be 2 become the 10a cubed b squared. It's going to be only multiplied by 2. 2 become the minus 15. It's going to be multiplied by minus 3. To become a to the 5, we need a to the second. To become b to the third, we need that b here. The numerator will be 5ab squared. Here maybe we can do it by mind, the simplification. The 5 and the 5 will eliminate. What will happen with the a? It's going to be a1 minus 3. It's going to be a to the minus 2. That means it's going to be a in the denominator. So maybe we can do it by mind. Maybe we can do it by mind and it's going to be okay. It's going to be 3 minus 2 minus 1. I'm sorry, that it's going to be on the bottom because it's bigger on the bottom on the denominator. In the case of the b squared, it's going to be 2 minus 2. It's going to be 0. That means we have only a 1 on the numerator and it's going to be then 2 minus 3a squared b. So this one can be an answer. Yes, this one can be an answer of this exercise. Or maybe somebody can say, okay, can I multiply the denominator part? Yes, of course. And maybe another answer for this one can be 2a squared minus 3a4b. And this one can be also an answer for this exercise. So as we saw in this exercise, in this case, the most important part it will be to remember the factoring cases in order to factorize our polynomials and see if we can simplify one part of the numerator with another part of the denominator after we have factors. Let's see another example. So let's see, on this second exercise, both of them, the numerator and the denominator, are possible to factorize them. So let's do it. On the numerator part, it's a difference of squares. So we can put it like 4b squared minus a to the 4. That multiplies 4b squared. Well, first the positive, then the negative. Minus a to the 4. On the denominator part, we have 4 terms, so we have two possibilities. Maybe it can be a perfect cube polynomial, but it's not a perfect cube polynomial because it doesn't have the specific structure of a perfect cube polynomial. So maybe we can do it by factoring by grouping. So let's see. Maybe these two have something in common, that it's going to be a squared that multiplies 4b squared plus a to the 4. We can also factorize the other one. It's going to be, they have in common 2b, and it's going to be 4b squared plus a to the 4. So yes, we can factorize it as factoring by grouping, and it's going to be 4b squared plus a to the 4. That multiplies a squared plus 2b. So this one is going to be 4b squared plus a to the 4. And we have also a squared plus 2b. So let's see. First, we can check out that this one and this one can get simplified. But what happens next? We haven't finished. Why? Because on the numerator part, this one, it's again a difference of a square. So we can factorize it and it's going to be 2b plus a squared that multiplies 2b minus a squared. All of it divided by a squared plus 2b. This one and this one, it's exactly the same, so it can be factorized also. So our only answer is going to be 2b minus a squared, all of it divided by 1. Something divided by 1, we don't need to put it as a fraction, so our answer is going to be 2b minus a squared. And this is going to be our final answer. So as we were telling at the beginning, the idea today is we need to factorize as much as we can. After factorizing, we can see if we can eliminate some of the factors, and we need to simplify it to the most minimum part that we can simplify. So let's see another example. So in this third exercise, it's going to be also very similar. Maybe we can think that we can factorize the first one because maybe we can think it's a perfect square trinomial. The square of this one is 2x, the square of this one is 3. But the middle one should be 12x because it's going to be 2 times 3 times 2, that it should be 12. So it's not a perfect square trinomial. Maybe we can think that it's a ax squared plus bx plus c trinomial, but we need to look for two numbers that when they get added, it's 6, two of them positive, and when multiplied, it's going to be 36. So it's going to be impossible two positive numbers that they give us 6 when they get added and 36 when multiplied. So the numerator part, it's not factorizable, so we can left it like the original one because it's impossible to factorize it. But the denominator, it's a difference of cubes. How to factorize a difference of cubes is going to be the cubic root of the first one minus the cubic root of the second one. And on the second parenthesis is the first one is squared, that it's going to be 4x squared. The multiplication of the two of them in positive, that it's going to be 6x. And the square of the second one in positive, that it's going to be 9. So if we check what we have in the numerator part and what we have in the denominator, they can get simplified. So our answer is going to be, I don't have anything on the numerator part, so it's like having a number 1. And in the bottom, it's going to be 2x minus 3. And that is going to be the actual answer for this exercise. So as I was telling you since the beginning in this topic, the important part is to remember the factoring cases. If we remember the factoring cases, it's going to be very simple. So here, let's make a little note. It's almost the same note as we did with the monomial denominator. What happens if we eliminate everything on the denominator and everything on the numerator? It's going to be almost similar, and it's super important for you because sometimes some people do it like this. They eliminate anything and they put that it's a 0. That's not correct, because if I eliminate everything on the denominator and the numerator, it's going to be a 1 divided by 1, so it's going to be only a 1. Yeah? So if I eliminate everything in numerator and denominator, our answer is going to be always 1, not 0. That's super important for you to remember. So let's see another example. So in this example, on the one that we have in the numerator part, we need to order it in order to check out if it's a ax squared plus bx plus c trinomial. So if we order it, we will need to check out two numbers that when they get multiplied, it's going to be minus 6. No, it's going to be plus 6 minus multiplied by minus 6x squared. So it's going to be minus 3x squared. Then it's going to be plus x minus 2. Two numbers that when they get added, it's 7. When multiplied, is 6x squared. It's going to be 6x and 1x. So this one is going to be minus 3x that multiplies x minus 2. So we can take out a minus 1 here, and it's going to be x minus 2. So it's going to be x minus 2 that multiplies minus 3x minus 1. So on this one, it's going to be on the numerator part, x minus 2 minus 3x minus 1. And on the bottom, it's a difference of squares. So we can factorize it at x plus 2 that multiplies x minus 2. So this x minus 2 and this x minus 2 can disappear. So our answer is going to be minus 3x minus 1. All of it divided by x plus 2. I'm sorry, it should be a plus 1. Here should be a plus 1, I'm sorry. So here is going to be a plus 1. Here it's going to be a plus 1. So this one can be our answer of this specific exercise. So remember, the important part is we need to remember how to factorize it. And when we have the answer of how to factorize it, it will be very simple to eliminate or simplify those specific factors that are the same on the numerator and the denominator part. Let's see another example. So let's see, in this exercise, the first thing we can do, maybe we can take out a common factor on both numerator and denominator. So on the first one, we can take out a 19. Those numbers, all of them are divisible by 19. And all of them have x. So it's going to be on this one, it's going to be 16x minus 4x squared minus 15. And on the bottom, it's going to be, we can take out a 2, I'm sorry, not a 2, only an x squared. And it's going to be minus 2x squared plus 5 plus 3x. So maybe we can order them, and it's going to be 19x that multiplies minus 4x squared plus 16x minus 15. And on the bottom, it's going to be x squared minus 2x squared plus 3x plus 5. So on all of them, it's going to be having a ax squared plus bx plus c trinomial. So let's see if it's possible to factorize them. So the first one I have is minus 4x squared plus 16x minus 15. So we need two numbers that when multiplied, it's going to be plus 60x squared. So let's see, it's going to be minus 4x squared. The middle one will be two of them, minus 15. Two numbers that when they get added, it's 16. When multiplied 60, 10, and 6. So it's going to be minus 2x that multiplies 2x minus 5. And on the other one, we can take out a 3. So it's going to be 2x minus 5. So our answer is going to be 2x minus 5 that multiplies 3 minus 2x. So let's see. This one is the first one. The second one is going to be minus 2x squared plus 3x plus 5. So we need two numbers that when multiplied, it's minus 10x squared. So it's going to be minus 2x squared plus x minus, because plus to become a minus, it's minus, plus 5. Two numbers that when they get added, it's 3, when multiplied it's 10, it's going to be 5 and 2. So we can take an x here, and it's going to be 2x plus 5. We can take a minus 1, and it's going to be, I'm sorry, here I forgot the sign. It should be minus 2x. So here you can take a 1, and it's going to be minus 2x plus 5. Our answer is going to be x plus 1 that multiplies 5 minus 2x. So we can change this one that we have here. It's going to be 19x that multiplies 2x minus 5 that multiplies 3 minus 2x. And on the bottom it's going to be x squared that multiplies x plus 1 that multiplies 5 minus 2x. So if we check out here, this one, 2x minus 5, and this one, it's almost the same. The only thing is that they have the different sign. So what can we do? We can take out a minus sign. We can put it like minus 19x, and it's going to be 5 minus 2x, 3 minus 2x, and on the bottom it's going to be x squared that multiplies x plus 1 that multiplies 5 minus 2x. I do that in order to eliminate this one with this one. Our final answer is going to be, of course, the x squared with the x. So our final answer is going to be minus 19 that multiplies 3 minus 2x, all of it, divided by x that multiplies x plus 1. And that will be our final answer. So as we saw here, it can be like many types of processes, but the important part is that we need to factorize whatever expressions we have, and we need to look for eliminating or simplifying those expressions. So let's see one last example. So it's the same as every exercise we have done. On the bottom part, we can factorize it. X squared minus two numbers that when they get added, it's 41. When multiplied, it's going to be 400. Maybe we can factorize the 400. It's going to be 2, 200, 2, 100, 2, it's going to be 50. 2, it's going to be 25. 5, it's going to be 5. 5, it's going to be 1. So maybe we can have 25 and 16. And those are going to be the numbers 25 and 16. On the bottom part, we can factorize the first expression, this one, as x plus 5 that multiplies x plus 4. The second one, it's going to be x minus 5, x minus 4. So what happens in the numerator? We can again factorize our expressions, and it's going to be x plus 5 that multiplies x minus 5, and it's going to be x plus 4 that multiplies x minus 4. The denominator is going to be already as we have it, x plus 5, x plus 4, x minus 5, and it's going to be x minus 4. So what will happen? X minus 4, x minus 4, x plus 4, x plus 4, x minus 5, x plus 5. So it's going to be 1 divided by 1. So it's going to be 1. Remember, if we eliminate every term we have, it's not going to be 0, it's going to be 1. So that will be the explanation for today's topic, that it will be how to simplify rational expressions with polynomial denominator. Remember, the most important part is to remember the factoring cases. So if you don't remember some factoring cases, you can go back and watch the videos of factoring. We will see each other next time.